Good morning. Good morning.
Good morning, sir.
Shall we start?
Yes, sir.
Last another two or three problems were left out in this module. That is a part of the module. Booking will start from Monday. The problem statement is like this. The shaft shown in figure is in equilibrium under two torques. Find the maximum shear stress in shaft and angle of twist at section C with respect to A. Assume rigidity modulus as ATGP. This is the problem statement. Let me write it. This is the shaft. Uh, is subjected to at this point 100 kilonewton mm, that is 100 sorry, this is not 100 kilonewton, this is 10 into 10 power 6 newton mm. Always you should convert into newton mm before solving the problem, because all my shear stress, length, everything will be solving it in mm. Therefore, to be consistent, we should maintain mm. Therefore, diameter at this end is 100 mm. Diameter here 50 mm. This is section A, B, C. This is fixed. This length is 5000 mm, and also this length is 3000. Also, you should convert it length into mm. So he has asked to what? Uh, find the maximum shear stress. Tau max, tau or tau max is equal to how much? In that T by J is equal to tau by R is equal to d theta by L. The tau what we got was tau max, right? Shear stress at the outermost fiber we took it, therefore it is tau max only. And then he has asked to find angle theta. Given rigidity modulus as 80 GPa, 80 into 10 power 3 Newton square. As usual, at each section A, B, and B, C, the shaft is under pure torsion. I'll consider a section here, XX, section BC. So like this, it is subjected to 10 power 6 Newton mm. This is the length of the shaft. If you curve your fingers along the length of the shaft, if your torque is in anti-clockwise direction, then it is positive. Whereas when you consider here, this is for my convention, I will always assume this torque to be acting away from the cross section. Okay, this is negative torque. TBC. Summation of torques should be equal to 0 minus TBC. If the torque is in only in this direction, then it is positive. If your thumb points away, then it is positive. Minus TBC plus 10 power 6 is equal to 0, or TBC is equal to 10 power 6 Newton mm. Let us go to section AB. This is 10 into 10 power 6. Shall I write 10 power 7? This is this is uh, 10 power 6, 6, and this is section B, C. This torque I will always take the torque acting away from the cross section. In this sense, this is TAB. Summation of torque should be equal to 0 minus TAB plus 10 power 7 minus TAB, sorry, minus TAB is acting like this in the opposite direction, minus 10 power 7. This is plus 10 power 6. If you curve your fingers along the length of the shaft, if your torque is in anti-clockwise direction, as in this case, then it is positive. If it is in clockwise direction, then it is negative. This is negative. That you remember. And also, as this is clockwise direction, it is negative. Let me give the statement. If curve your fingers in the direction of torque along the length, if the torque are curving, or if the torque or if the torque is in counterclockwise direction, torque is in counterclockwise direction, then it is a positive torque. If you curve your fingers along the direction of torque, along the if you curve your fingers in the direction of torque along the length, if the torque is counterclockwise direction, of the torque is in counterclockwise direction, then it is a positive torque. Why I am specifying along the length? Because there can be instance like a shaft can be given in this direction also. Shaft can be given, it can be given like this also, like this also. Then this is point A, this is point B, then this will be the L, 0 to L, 0 to L. Then counterclockwise torque in the sense, then this is counterclockwise torque, then this is the counterclockwise torque. Then this will be positive in this case. Okay? Along the length you should take. Don't worry about that. That you should understand like that only. Okay? But according to when the support is at the left hand, you should remember that this is, if the torque is acting like this, that one more torque is acting like this. This is clockwise torque, which is, if you curve your fingers like this is negative torque. This is counterclockwise torque. This is positive torque. Remember like that. This is 0 to L. Okay. If you curve your fingers in the direction of torque along the length of the shaft, if the torque is in counterclockwise direction, then it is a positive torque. Okay. Now minus TAB minus 10% 7 plus 10% 6 is equal to 0. Or can you tell me what is TAB? TAB is equal to how much? How much? How much? Nikala, Raghavendra, Sugand, Sushil, Shipatap, Ruti, how much you got?
minus 9 into 10 power 6.
Minus 9 into 10 power 6. Just by seeing to into the tons, writing only 10 power 100, then it will go wrong. Be careful. Minus 9 into 10 power 6 Newton mm. Okay. TAB, TBC we got. It is asked to find the maximum torque. T by J is equal to tau by R is equal to G theta by L. At tau is equal to TR by J. Tau AB is equal to TR by J of AB, which is equal to T of AB. T of AB is minus 9 into 10 power 6, minus 9 into 10 power 6 into diameter in the region AB. It's 100 mm. Let me take it as 50 mm. 50, R is 50 by J pi into d power pi into d power 4 by 32. Can tell me what is tau AB? Tau AB. Similarly, tau BC, which is equal to TR by J of BC in the region BC. In the region BC, T is 10 power 6, dia is 50 mm. 10 power 6 into 25 by pi into 50 power 4 into 32. Can you tell me tau BC? He has asked to find the maximum shear stress, which is in the region AB. Because the torque is maximum, it has to be in the region in the AB only. For curiosity, I have done both the section AB and BC. Can you tell me how much you got? Minus 9 into 10 power 6 into 50 into 32 by pi into 100 power 4. How much? Is it minus 45.836?
Yes, sir. Minus 45.859.
Okay. Minus 45.859 Newton per mm square. Can you tell me the region BC? 10 power 6 into 25 into 32 into by pi into 50 power 4.
40.76, sir.
40.76 40.76 Newton per mm square. Therefore, tau max is in the region AB, that is tau max, which is equal to minus 45.85 Newton per mm square. Okay. Next, is asked to find theta. We know that theta total, which is equal to theta CA, which is equal to theta BA plus theta CB. It means to say that theta CA in the sense total angle of twist of C with respect to A, total angle of twist of C point C with respect to A, that is theta CA is equal to angle, that is theta C minus theta A, which is equal to theta B minus theta A plus theta C minus theta B, which is nothing but equal to your theta C minus theta A only. This will cancel, is equal to theta c minus theta a. Since theta a is fixed, we will get theta c only. But in order to find theta c, I need to take theta ba plus theta cb. Okay, that is t by j, t by j is equal to tau by r is equal to g theta by l, or theta is equal to tl by eta is equal to TL by Gj. Theta is equal to TL by Gj. Theta AB, let me write, theta total is equal to theta BA plus theta CB is equal to TL by GJ. BA and AB is on the same. If you want to write BA on the TL by GJ, CB and BC are on the same. CB, which is equal to torque in section A, torque in section AB, that is torque in section AB is minus 9 into 10 power 6, minus 9 into 10 power 6 into length of this section AB is 5000 mm by G is constant toward the material 80 into 10 power 3 into pi into diameter is 100 power 4 into 32 plus T in section BC is 10 power 6, I think, 10 power 6, 10 power 6. Length of this section is 3000 by G is same 80 into 10 power 3 into pi into 50 power 4 into 32. Can tell me to theta T, which is equal to theta C. Can tell me this value. This is minus 9 into 10 power 6. How much you got? Is it 3.8197 into 10 power minus 3? 3.819 into 10 power minus 3.
3.8 into 10 power minus 3.
Okay, convert it into degrees and tell me theta C 3.819 into 180 by pi, which should be equal to into 10 power minus 3. Is it 0.2198 degree? That means counterclockwise is positive. We'll go ahead. Next problem. This is shaft in series. Until now, we discussed about problems like shaft subjected to combined load. That is different torques. Okay, see, and the shaft with the different torques. In the previous problem, it was a uniform shaft. These are all uniform shafts, but subjected to various torques. This problem is step put shaft, either different material or different dia. This is step put shaft with different torques. Next, we will discuss about series shaft and parallel shaft. Okay, Rakesh sir is unable to take the class. I will continue his class. Okay, another next class also we will continue for some time. The problem statement is having another class. The problem statement is like this. These are called as statically indeterminate shock because we require extra boundary conditions to solve this problem. Okay, only the summation of torque is equal to 0 is not sufficient. An extra compatibility condition is your total twist is equal to 0, summation of angle of twist is equal to 0. We require that. We'll go ahead and solve that from two solid shaft AC and BC of aluminum steel. Let me read the problem. Two solid shaft AC and BC of aluminum and steel are rigidly fastened together at C and attached to a rigid support at A and B as shown in figure. Let me read the figure. Two shaft, two solid shaft A, C and BC of aluminum and steel are rigidly fastened together at C and attached to rigid support. A and B are rigid supports. A torque of 300 Newton meter is applied at C. Since it is a positive torque from this end, you will give the sketch also 300 into 10 power 3 Newton mm. Calculate the shearing stress in each material. Tau AC is equal to how much? Tau CB or BC is equal to how much? Angle of twist at the junction at A and B. Theta C is equal to how much? Given rigidity modulus of aluminum is 3 into 10 power 4 Newton per mm square. Rigidity modulus of steel G steel which is equal to 9 into 10 power 4 Newton per mm square. This is the problem statement. How do we go ahead? As usual, I will assume reaction torque. I will assume reaction torque. We need to assume the reaction torque. I will assume the reaction torque as usual counterclockwise. This is T. Since this is the reaction torque, okay. I will assume this as okay. Give me a moment. A B C. Okay. I will assume this as TRB, and also at this end I will assume this as TRA. Okay. Next, as usual, I assume a suction here, XX. Now let's consider suction. This suction, this is like this. Circular torque TRB, and this is a suction. Okay, this is torque TRB under this suction torque TBC. Okay, for equilibrium, summation of torque should be equal to 0. This is acting in the counterclockwise direction. Plus TRB minus TBC is equal to 0. Or TBC, torque in section BC, is equal to reaction torque TRB. I'll put a section here, XX, X2, X2. I'll take this. This is torque TRB. This is 300 into 10 to the 3. This is suction. This I have not considered torque TRA. This is suction. I will assume TAB acting like this. Summation of torque should be equal to 0. This TAB is acting in the opposite direction, clockwise direction, minus TAB. This is counterclockwise direction. Plus 300 into 10 power 3 plus TRB is equal to 0, or TAB which is equal to minus 300 into 10 power 3 plus 300 into 10 power 3 plus TRB, right? TAB 310 power 3 plus TRB. Okay, but you should observe that when you subject a shock to when you apply a torque or when you fix the two bars in series, and if you apply a load, we know that summation of deformation theta AB, sorry, theta AC plus theta CB is equal to 0. Total deformation is 0. There can be 2 mm deformation in this direction, but there is negative 2 mm deformation in this direction. So total deformation is 0. Theta AC plus theta CB is equal to 0. Okay. Next, theta we know. Theta is given by TL by GJ of AC plus TL by GJ of CB is equal to 0. TL by GJ of AC plus TL by GJ of BC is equal to 0. Right? CB or BC is equal to 0. T of AC, torque in AC, which is nothing but, sorry, TL by GJ, this is AB, sorry, this is AC. This is AC, T of AC. This is T of AC, T of AC, T of AC. This is T of AC. Okay. T of AC, which is about 310 per 3 plus TRB, 300 into 10 per 3 plus TRB, length of this shaft, AC, which is nothing but how much? AC, here not here given 2000 mm, and this is 1000 mm, 2 meter and 1 meter into 2000 divided by G, GT modulus of aluminum. This aluminum, it's 3 into 10 power 4, 3 into 10 power 4 into J, pi into d power 4. Diameter of this section as a given, its diameter is given, dia 60, dia 40. Pi d power 4 by 32, pi d power 4 by 32 plus T, T in section, AC is over, T in section, CB we want, CB, which is nothing but CB or BC, which is equal to TRB, TRB into length L is 1000 mm divided by G, G in this case is 9 into 10 power 4, okay, 9 into 10 power 4, 9 into 10 power 4 into pi, diameter is 40 mm, pi d power 4 into 32. Can you tell me it should be equal to 0, or you can take 0 on the left hand side. Can you tell me what is TRB in terms of TRB? TRB is equal to, you take your alpha is equal to 0 is equal to that equation alpha, you should do like that. How much you're getting? How much are you getting? Yes. Raghavendra, how much are you getting? Mekala?
0.0157.
Correct order. 10 for 3, 2000. No, 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 no. Somewhere you're gone wrong. Are you getting minus 162,711.864 Newton mm? Minus 162,711.864. 300 into 10 power 3 plus TRB into 2000 into 32 by 3 into 10 power 4 by into pi into 60 power 4 plus TRB into 1000 into 32 by 9 into 10 power 4 into pi into 40 power 4. How much? Sugun, others?
Minus 162.54.
Minus 162,711.864. Are you getting that? Let me write it. Minus 162,711.844 Newton mm. Are you getting this? 864. Are you getting this? Mekala. Did you got this?
I'm getting minus 162.542.
542. No, 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 no. Check whether you have taken all the units that power properly. The 60 power 4, 10 power 4, 9 into 10 power 4, 40 power 4. Check it out. You should not take 300 into 10 power 3 plus TRB into 2000. You should close the bracket and then you should multiply it. Or you can do 2000 into 32, 300 into 10 power 3 plus TRB into that. Others, anybody getting this answer? You should get this answer. Dutya, how much you got?
Sir, I got minus 60 something, sir.
Why you are doing wrong? You should use alpha 0 is equal to this equation. Wherever TRB comes, you should replace it by alpha x. So that is, are you aware of that? You're using the equation in your calculator? But be knowing by this time. Are you aware of that?
Yes, sir.
And then why you are getting wrong? Calculator itself calculates it. Then it should not. There should 300 into. I'm getting minus 162,711.864. Check it out properly. I'll wait for 2 more minutes. Once again, go back and check whether you type the equation properly. This is 1000. The TRB into 1000 into 32. Rakesh, Shugun, Sushil Kumawat, are you doing?
Yes, sir.
How much you got? Okay, go ahead. TRB is equal to this much, but for equilibrium, summation of torque should be equal to 0. That is TRA plus 300 into 10 power 3 plus TRB, whatever is that is all are in clockwise direction. That is all in counterclockwise direction. All are positive torques. Let me write it. TRA plus 300 into 10 power 3 plus TRB must be equal to 0. These are all in counterclockwise direction only along the length of the shaft. Along the length of the shaft, these are all in counterclockwise direction. Therefore, 310 power 3 plus this thing should be equal to 0. But TRA we don't know. TRA plus 300 into 10 power 3. TRB is minus 162.711 into 10 power 3 is equal to 0. Therefore, TRA is equal to, this will be equal to how much? 300 minus 162.77, this will be around minus 137.268 into 10 power 3 Newton mm. This is your TRA. Okay. He has asked us to find the reaction torques, shear stresses, and angle of twist. We have found the reaction torques. Let us go ahead and find the shear stresses. We know that according to the torsion equation, T by J is equal to tau by R is equal to G theta by L, or tau is equal to TR by J, tau, or tau AC, tau AC, tau BC, tau AC is equal to tau AC is equal to TR by J of AC. TR of AC, uh, let me go back. If you come back to this equation, TBC is equal to TRB, TBC is equal to TRB, TRB is equal to minus 162. Therefore, TBC is equal to minus 162.711 into 10 power 3. TBC minus 162 point how much? Minus 162.711 into 10 power 3. And TRA, where we wrote that equation, TAC is equal to this equation, and then uh, this is TBC. Give me a moment. TRB is equal to TAC is equal to this much. Okay, TAC which is equal to 300 into 10 power 3 plus TRB minus 162.711 into 10 power 3 which we calculated TAC, which is equal to, that is minus 137. Give me a moment. Okay, this will be 300, this will be plus 137.288 into 10 power 3. Hope you can understand this. We got these two equations. TS is equal to 300 into 10 power 3. Sorry, this 3S is equal to 300 into 10 power plus 3 TRP. Therefore, TS is equal to 137.288 into 10 power 3. But the reaction torques are TRA minus 137 and TRB, which was equal to minus 162. Okay, we'll go to this. Tau AC is equal to TAC. TAC, how much you got? 137.288 into 10 power 3. 137.288 into 10 power 3. Radius of shaft AC is how much has given? Dia 60 into 30 by J pi into 60 power 4 into 32. Can you tell me this? Tau AC, tau BC is equal to T by R by J of BC, which is equal to TBC. TBC we got it as minus 162.711 into 10 power 3, minus 162.711 into 10 power 3 into J. J in this case is 40. R is 40. Therefore 20 by pi into 40 power 4 into 32. Can you tell me this? may end up. I will continue with the next class also. After 10 minutes, I will schedule a link. I'll schedule a meeting. Can you tell me how much you are getting? TR by G of AC, TR by J of BC. How much? AC, tau AC. How much Ravindra? Dhruti? Tau AC? It is aluminum. Tau AC is aluminum. Tau BC steel. How much? 137.288 into 10 power 3 into 13, 30, 32 by pi into 60 power 4. How much? Social Kumawat Sugan package T. How much Dhruti? Mekala, how much?
3.23.
3.23 tau aluminum AC, right? 3.23 MPa or 3.23 Newton per mm square. 3.23 Newton per mm square. This section tau steel, tau BC is equal to how much?
Minus 13 points.
Okay, minus 12.948 Newton per mm square. We got shear stresses, we got this reaction forces, we are left with angle of twist. Theta, what is the relation we have wrote? We have wrote it theta AC is equal to T3 plus theta CB is equal to 0. Theta AC plus theta AC or theta CA plus theta CB is equal to 0. Let me write it as theta CA is one and the same. Theta CA plus theta CB is equal to 0 or theta CA is equal to theta C minus theta CB or theta CA in the sense which is equal to theta C minus theta A. Since theta A is equal to 0, this is theta C only. Theta CA is equal to theta C. You can either take theta CA or theta CB, which should give the same theta C. It is the angular twist at the center. We know that theta is equal to TL by GJ, theta C A, which is equal to theta C, which is equal to TL by GJ of C, which is equal to torque in section AC. AC, it's 137.288 into 10 power 3, 137.288 into 10 power 3. Length of this section AC is 2000 by G. G in this section is 3 into 10 power 4. Okay, 3 into 10 power 4, and then J pi into diameter 60 pi d power 4, 60 power 4 into 32. Can you tell me theta? What is theta? Are you able to understand? Either you can take theta CB. Theta CB also is one the same. Theta C minus theta B or theta C. This is theta CA minus, sorry, give me a moment. Theta C, this is theta CB. Therefore, theta B is 0. Theta B is 0. Therefore, we will get theta B is 0. Therefore, we will get theta C only. Okay. Minus theta CB will get theta C. How much you are getting? 137.288 into 10 power 3 into 2000 into 32 by 3 into 10 power 4 by into pi into 60 power 4. Are you getting 7.193 into 10 power minus 4. 7.193 into 10 power minus 3 radian converted into degrees later. Are you getting this answer? Duti, Mikala?
Yes,
Yes,
sir.
sir.
Okay, I will stop at this point. Last problem, shaft in series, we will solve it. Okay, another 10 minutes, I'll schedule a link and send you. That completes your torsion part. Next week onwards, we'll look into buckling.